Use the given data to complete parts A through D. Here we are given a table. We have x coordinates and y coordinates. Calculate r using this formula. So we'll do that first. Now if you notice in the formula, we have some symbols. We have a summation symbol. It's that right there. That means you are adding something together. And what are you adding together? You're adding together the product of x, y. Here we have the summation of x. You're adding together the x coordinates, or the x values. Here we have the summation of y. You're adding together the y values. We also need to add together x squared values, and we need to add together y squared values. So we need a sum of each of those separate types of values. So this is best done using a table. So we'll start our table. So for A here, we know n equals 5 because there are 5 ordered pairs. We need x, we need y, we need x squared, we need y squared, and we need xy. These are kind of big numbers, so we're going to need to space them out a bit. Alright, so the first thing you do is you just list your x values straight down underneath your x column. Then you list your y values under your y column. You might want to separate them like this. Okay, I'm going to do the first row across, and then you do the rest of the rows the exact same way, but the video will pause after I do the first row, and then the rest of the table will just be completed up until where we need to add the columns. So first we have to do x squared. So 1,500 squared. Then we need to do y squared. 650 squared. Then we do x times y. 1,500 times 650. The video will pause here, and you might want to try to finish the rest of this table on your own, and then all the numbers are going to show up on the table. Okay, now take a moment to check your work here. What I've done is I've completed each row the exact same way that I completed the first row. Next step is we need to add each column. So, for example, this column will be the sum of x. This column will be the sum of y. This column is the sum of x squared. This column is the sum of y squared. And this column is the sum of x times y. So we just add each column straight down. Okay, so we have some fairly large numbers here. These are the values we are going to be putting into our formula. Okay, now, the formula, r equals. It starts out with n, so that's 5. Then it says times the sum of xy, so that's the sum of our last column. Then minus. Then it says the sum of x. that's the first column, times the sum of y, that's the second column. So we're dealing with all of the sums of the columns. Now our denominator is broken up into two parts, two square roots. So first, under the square root, we have n, so it's 5, times the sum of x squared. So that's the third column. Minus, then it says the sum of x in parentheses squared. So that's the first column total squared. Then another square root. Then we have n, which is 5, times the sum of y squared. So that's the fourth column. Minus the sum of y in parentheses squared. So what we can do is we can get the entire numerator as a single value and then simplify what's under each square root. We'll do that first. So there's our numerator. Then we're going to get a single value for each square root. Okay, then, now that we have each portion simplified, we go ahead and type this in our calculator. If you're typing this in your calculator, make sure your entire denominator is in parentheses. And then many times the calculator, it'll need parentheses around the numbers that are in the square roots as well too. So typing this in our calculator and rounding to 4 decimal places, we get 0.9469, which is R, which is the Pearson correlation coefficient. Okay, now, on a scale, our values will always be between 1 and -1. Our R value is very close to +1, which indicates the possibility of a strong positive relationship. When R is positive, there is a positive relationship between x and y. When R is negative, there is a negative relationship between x and y. All right, so positive relationship would look like this. If we have x and we have y, this is positive. A negative relationship would look like this when you graph the scatter plots. If it's a strong relationship, that means the numbers are very close to looking like a straight line. A weak relationship would be near 0, and the numbers on a scatter plot would be all over the place. So they wanted this for A, so we're done with A. B then says to test whether there is sufficient evidence to support the claim of a linear relationship. So the null hypothesis is that there is no linear relationship. And the alternative hypothesis is that there is a linear relationship. And we're going to test this at the 0.05 significance level. So we need the absolute value of R, and we need to compare that to the table. So we go to table A6, critical values. We look under alpha equals 0.05, n is 5, it says 0.878. 0.878. So we're greater than 0.878. When you're greater, that means you reject the null hypothesis. And then there is evidence of a linear relationship. So we are rejecting the null hypothesis that there is no linear relationship, and we are stating that there is evidence that there is a linear relationship. Okay, let's look at C. For C, we're going to use the formulas here to come up with y hat. So B sub 1, and just plugging information into the formulas, we have it all. It's going to be 5 times the sum of xy minus the sum of x times the sum of y, all over n, so 5 times the sum of x squared minus the sum of x in parentheses, and then squared. For time's sake, I'm not going to simplify, I'm just going to go right to the answer. So B sub 1 is 0.4291. B sub 0, the formula, is the sum of y times the sum of x squared minus the sum of x times the sum of xy, all over n times the sum of x squared minus the sum of x in parentheses squared. And for time's sake, I will just go right to the answer. Now our formula, y hat, equals b sub 0 plus b sub 1x. So y hat equals negative 4.6218, and then it's plus b sub 1, so b sub 1 is positive, so plus 0.4291x. So this is the regression line, the equation for the regression line. So y hat negative 4.6218 plus 0.4291x. All values are rounded to 4 decimal places. You would just round to whatever they were asking you if you were doing this in homework or something like that. So now, looking at D, D says, what is the best predicted value of y for x equals 300? All right, now, if, up here, if you did not find evidence of a linear relationship, you use the average of the y values, y bar, so the mean of the y values. That's if you do not find evidence of a linear relationship. If you do find evidence of a linear relationship, you use your regression equation. Since we did find evidence of a linear relationship, we are going to use our regression equation, and we substitute 300 for x. So plugging this number in, and we'll just round to 1 decimal place. Actually, we'll round to no decimal places, the whole number. It'll be similar to the values on our table then. We get y hat is approximately 124. So the best predicted value for y when x is 300 is 124. And you can see these numbers are kind of all over the place, but we do have a 300 on our table, which indicates 125. But we also have a y value of 125 for 500. So if we were to draw the scatter plot, we would see that some of these would be slightly away from our regression line, where others would be closer to our regression line.